Hello everyone. இன்னைக்கு வந்து I'm going to discuss about Kirchoff's voltage law or this circuit law. So this is something very basic. Yeah, I think most of you know about it, but for the sake of those who are new to it, let us discuss it. But அதுக்கு முன்னாடி I just want to show you this and I want to ask you a small question. You can see the video. Idla LEDs is getting turned on. What device am I using there? என்னோட ப்ரீவியஸ் வீடியோஸ்லாம் பார்த்துருந்தீங்கன்னா நிச்சயமாக உங்களால் ஆன்சர் பண்ண முடியும். திஸ் கொஸ்டின் ஐ வாண்ட் ஆஸ்க் பிகாஸ் I want to understand whether I'm able to communicate with my viewers properly. And நான் கம்யூனிகேட் பண்ணுறது உங்களுக்கு ரிஜிஸ்டர் ஆகுதா? For that reason, I want to understand this. And this LED's connection and the voltage, how much current, what type of LED, what will be the value of voltage for each type of LEDs. Either one that I'm going to cover in the next video after we do this circuit. So once we know the circuit law, we can move on to any circuit. So that is going to be the next video. So just wait for it. And now let's just get started with our KVL.
So KVL, it's called Kirchoff's voltage law. It's a scientist's name, so it's named after scientist Kirchoff. It similarly we also have Kirchoff's current law, but Kirchoff's voltage law நம்ம focus பண்ணோம்னா it's something that is inevitable. It's very commonly used, and we cannot even think of using a circuit without Kirchoff's voltage law particularly. Current is also important, but because we are mostly using voltage reference and voltage vechchu dhaan measurements are easy with respect to voltage, so that's why this is very oftenly used in every circuit. So we cannot avoid or we cannot skip it, and we should not do it wrongly. We should be very clear with these fundamentals. Okay, and that much important it is, and that much easy also it is. So what this law states very simply like the sum of all the sum. This is the sum. Okay, the sum of all the voltages in a closed path. It could be a closed path in or it could be a part of a circuit which is closed also. Closed path or a closed circuit is equal to 0. அதாவது நம்ம எல்லா voltages in a circuit add பண்ணோன்னா, and if that is a closed path where the current returns again to the same place, then in a closed circuit the sum of all the voltage is going to be 0. That means if you have a supply some circuit, like let me not mention anything, இது மாதிரி ஒரு சர்க்கியூட் இருக்குது அப்படின்னா, இப்போ இதில் ஒரு V1 இருக்கும். this V1 will be the voltage across the source, and V2 will be the voltage across this R1. V3 is the voltage across this R3 element அப்படின்னா, sum of all this voltages V1 plus V2 plus V3 is equal to 0. This is what Kirchoff's voltage law states. So இதை நம்ம இன்னும் like if you go in detail and see, suppose if this is a 5 volt supply voltage, இதுக்கு வேல்யூஸ்லாம் கொடுத்து நம்ம பார்த்தோன்னா, அண்ட் ஒரு ரெசிஸ்டர் இருக்குது R1, another resistor R2, இப்போ கரண்ட் I ஃப்ளோ ஆகுது அப்படி இருந்ததுன்னா, ஸோ இப்போது நம்ம இதுக்கு ஒரு KVL எழுதும் போது this is how we will write, but instead of writing V1, V2, V3, whenever there is a current flowing, to be more precise, let us say current travel ஆகும்போது there is going to be voltage drop seen across every element. So இந்த R1 வழியாக current flow ஆகும்போது is flowing through from a higher potential to a lower potential, because it's a current always moves from a higher potential to a lower potential. So இதில் current போகும்போது there is a voltage drop. Similarly, like let's put it in different colors so it will look a little better. So current போகும்போது there is a voltage drop from this potential is at higher potential compared to this potential. Similarly இங்கே வந்து it's going to be higher potential compared to this potential, because the current is moving from top to bottom, right? So you have the like sign convention or the voltage drop across each element. So the power supplyன்றதுனால already it has a like notation for plus and minus. So now let us write the KVL for this closed path in this direction. Let's move from the power supply and go and write the whole equation. If we write like that, you will see first we'll start with 5 volts plus the voltage drop across the resistor R1. It's going to be like minus I into R1. Minus I into R1 because there is a voltage drop. You can see there is a voltage drop from plus to minus. It's moving, so voltage drop is there, so it is ending with a minus. So minus I1 R1, then plus again. When you write for R2 also, the same thing happens. There's a voltage drop when the current I is going from here to here. It's a voltage drop. That's why it becomes minus I into R2 also, and the summation is going to become 0. So this is how. So if you know the value of R1, maybe if it is 15 ohm and R2 is equal to 22 ohms, then you can easily find what is the value of I. Because it's a linear equation. So as simple as that. Okay, so this is how this works. KVL works in any circuit. Suppose இது என்ன வெறும் க்ளோஸ் சர்க்யூட்டுக்கு மட்டும்தான் அப்ளை பண்ண முடியுமா? Yes, this by definition can be applied only to the closed circuit, but the beauty of this KVL extends to any branch or any segment of the circuits also. Suppose if I have a circuit, just I pick up some part of a circuit where it says it is 2 volts here. I don't know what is the voltage over here. இங்கே என்ன voltage Vx எனக்கு தெரியாது, but I know it is a 100 ohm resistor here, it is a 20 ohm resistor here, and there is a current flowing of 1 ampere current is flowing. அப்படின்னா if I know these details, still I can apply this. Even if I don't know a lot of details about it, still I can apply KVL for even a segment of a circuit. How we can do it? Let me write the equation. So KVL, for KVL the most important thing is, எப்போ KVL எழுதுனாலும் first thing we should do is we should mark the current direction. The current is moving from here to here. Let's say even if it is an assumption direction, we have to mark one assumption direction at least. Current is moving like this, so plus minus voltage drop is there because it's a resistor. Again plus minus because a voltage drop is there and current is moving from a higher potential to a lower potential. So always current moves from higher potential to lower potential. So when the current moving through a resistor, this point is a higher potential, this point is at lower potential. Similarly, this point is a higher potential, this point is a lower potential with respect to just this element, if you see. So now let's write. So if you start from this point, 2 volt, right? 2 plus the voltage drop across 100 ohm resistor is minus I into 100. Why? Because the resistor ends with a minus. There is a voltage drop, and then again there is a voltage drop across 20 ohm resistor, so again plus minus of I into 20. Instead of putting 0 at this point, because it's not 0, it's not a closed path. If it's a closed path, we can equate to 0, but it is not a closed path, so equate it to whatever the potential at the wherever you're stopping. I'm stopping at this point. Potential at this point is unknown and it is marked as Vx, so I'll put Vx. That is it. So we can apply KVL. If you apply KVL in a closed path, you equate it to 0, like here. If you apply KVL in some segment of a circuit, equate it to the potential where it ends, whichever point it is. That's it. Simple as that. And another thing, I'll give you one more example or one more situation where we might face in our circuits. Same R1 irukku, R2 irukku, and but here the current is traveling in this direction, opposite direction. We saw it in other direction, now I'm saying it in this direction, but here is okay. So but I'm going to write let's say here it is V1, here it is V2. We don't have to know any potential, we'll just write like this and see. So இப்போ KVL எப்படி எழுதுறது? Suppose if I'm starting from V1, we have marked current direction, no? So current direction mark பண்ண உடனே should mark the like what is the plus and minus, like what is the potential, where is the drop. So the current is moving like this, so current enters and leaves, drop goes like this. For this resistor R2, current enters here and leaves here because current goes from a higher potential to a lower potential. Always mark like this, okay? Alright, so now in the marking பண்ணியாச்சு. இப்போ வந்து I can start writing the KVL. So if I'm going to start writing from here, I can say V1 is the point I'm starting, plus the drop across the resistor R1. What's the drop across the resistor R1? That is here இப்போ நான் மைனஸ் போட மாட்டேன், ஏன்னா it is ending with a plus, because my notation says I'm traveling in, don't take so much of my explanations right now. If you can understand, take it, otherwise just follow the nomenclature. uh, just because the current direction and the way I'm moving right now are in opposite, that's why this thing comes up. Okay, so now it ends with a plus. I am going to say plus I into r1, and again it ends with a plus, so again I into r2 equal to, so what is this potential here? It's v2. Got it? So what is the direction of the current and in which direction I'm writing KVL, all this also determines the equation. Whenever you are about to write a KVL for any circuit, whether your current direction is known or unknown, you mark one assumed current direction. Suppose நம்ம assume பண்ண current direction தப்பாக இருந்தால், the maximum thing it can go wrong is the I value you are getting, no, it will be negative. If I value get is negative, then whatever the current direction we have assumed is opposite to the actual flowing direction of the current. That is all it's going to make the difference, or that's all it's going to be coming up in the results. It's not a mistake at all. Just by looking at the negative sign or a positive sign in the final value of I, we can say whether our assumed direction of the current is right or wrong. Okay, but this video was more about telling about KVL. So if you understood, like writing KVL is all about the summation of all the voltages in a closed path is equal to 0, and KVL can also be extended to any open segments. But when you use it for an open segment, you equate it with the final voltage where you leave it. Instead of putting 0, you equate it for the final voltage where you leave it. And the current direction matters, and after assuming the current direction, you put the voltage drops, like what is the plus minus sign. So how to put that, I've told you. Then based on that, you can have the minus sign or plus sign over in your KVL equations. So this is for equations, and this equations we will use very often in our practical circuits also. That's why I want to make sure you know all this. So first one was your definition itself. I think that is clear. So you can use it in a closed path with equating it to 0. In any segment, you can equate it to the with respect to this, whatever is the final point you are leaving. And the another important point is that always current travels from a higher potential to a lower potential, and whenever there is a resistor, it's going to be a voltage drop. So when the current travels to a resistor, there is a voltage drop. In the இடத்துல பார்த்தீங்கன்னா, like in this part, if you look, the current is traveling like this. So current இப்படி move ஆகும்போது there is a voltage drop obviously seen across these resistors, because this point is higher compared to this point's potential, because current is moving from right to left in this case. And so the equations, when we write from V1, it all becomes plus plus, because the way we are moving is in opposite to the direction in which actually the current is flowing. Okay, I hope this is clear. So now let us see the demonstration part. So let's set the power supply. Power supply, keeping it at 5 volt. So ground at the first breadboard la na connect pandra oru point la. Okay, some point, and another point in the breadboard I'm connecting the positive of the power supply. Just for understanding sake, like number circuit eppadi potumo appadi irundha it will be easy for you to visualize. For that reason I am keeping it this way. Then I'll take 2 resistors of some random values. So let's measure the resistance also of this R value and paathukalam. So first resistor value measure pandren. So first R value paakradhukku I'll put this, see evlo varudhu, 9.7k, around 10k. So 9.7k varudhu. Let's put this directly from the power supply positive level. I'll put it at 1 point here. Okay, just zoom it a little bit. So it's clear here. Next another resistor எடுத்துட்டு, it is 220 ohms, around 220 ohms இருக்கு. With இப்போ வந்து this goes to the ground directly, but to just make it look like the same circuit I've drawn there, I will connect it with another wire. Okay, just see closely. So take a jumper, bring it to the ground. So இப்படி தான் கனெக்ட் பண்ணணும் இல்லை, just for the sake of making you visualize the same closed circuit like this. From the positive current goes like this and back to the ground. Okay, this ground because it's a negative from the power supply. Okay, so now இப்போ வந்து we know it is 5 volts. Total supply voltage is 5 volts. So 5 volts தான் should be divided across these two R1 and R2, right? So this 5 volts should be divided across R1 and R2. So எவ்வளோ voltageன்றதை இப்போ பார்த்துக்கலாம். Okay, we'll again look into the multimeter clearly. Multimeter பார்த்துக்கோங்க. We will put it in the voltage mode and then see first let me put find V1. P1 வந்து இது ரெண்டு எண்டுக்கும் போடுறது is V1. So how much voltage you are able to see? 4.9 volts because this is 9.9k, right? Compared to R2, R1 is so high, so R அதிகமாகும் போது your voltage also is going to increase. Similarly இப்போ இங்கே பார்க்கலாம் how much is the voltage drop across the second resistor. 0.109. So see, so this was around 4.9 plus 0.01 makes 5 volts. If comparable values போட்டோம்னா you will have comparable voltages here also. So let me try to pick another resistor of something similar value. So this is coming around 21k. 21k resistor இங்க நான் replace பண்ணி பார்க்குறேன். So let me remove this one and put this 21k over here and then see how this works. Okay, R2 replace பண்ணிருக்கேன். So this is 10k, this is 21k around. So how this values are affecting, we'll see again in the voltage mode. So just look into this, how much voltage. So V1, that is a drop across the resistor R1. Drop across the resistor R1 is, you can see it's around 1.5. முதல்ல எவ்வளோ இருந்தது 10k 9.9k. the R1ல it was 4.9. now comparable resistors போட்டோன்னா what is the voltage drop across this R1 is 1.57. remember 1.57. so R2ல எவ்வளோ drop இருக்கு பார்க்கலாம், it's 3.4. so 1.57 plus 3.43, so around 5 volts. So again you can see the how this 5 volts is divided across R1 and R2 based on the resistance value. Current also will like if in the loop plus the same current is flowing. For R1 R2 there will be one current. For if the R values changes, again different current will flow. But ஒரு circuitல same current தான் flow ஆக முடியும். இப்போ இந்த ரெண்டு value of R க்கு some amount of current is flowing, that is I. So now you can see how KVL works. Like 5 volts கொடுக்கும் போது that 5 volts is divided across the two resistances across two resistances in the closed path, right?